Hi guys, long time no see. I'm finally back in Thailand. My time in Austria was good but very intense. In this video we're going to talk a little bit about what you will see in the near future on my channel, and you will also suspect already that if you see these two inverters on the table, that something is going on here. So these two inverters, unfortunately, they are both from the Powerwall. They are dead at the moment. And I took an initial look on it, and I will tell you what I think is the problem with them. In this video we're not going to make a repair attempt, but just trying to initially find out what is going on. And what is going on might have also something to do with this here. This is a SPD from inside of my system, and it triggered. Not just triggered, it actually blew one side. And yeah, so this might be also an indication why these two inverters both failed on the AC side. So happy to be back with me, and I hope you will find some interesting things here today and also in the next videos then. Let us first go behind our coffee shop. So this is the place where I have my up till now biggest solar area. It's 3 areas here, 3 inverters. You might remember how we installed the last array here. And about a month ago my wife told me that something is not correct. The energy bill actually was extremely high, so extremely high for our taste. I said to her she shall check the inverters, and we found that these inverters have been offline. So the only thing I could imagine was that the AC supply for this box here and the inverters was down, and it was like that. We again had a faulty main breaker. So I told my wife by phone, I instructed her how to change that breaker. She did it, and yeah, the system worked again. But when I arrived now from Austria, I also noticed something else. So this guy here was built in there, and as you can see, the left side of the SPD, this is a AC SPD, triggered. So this is the first time I see an activated SPD. So we had a failed main breaker and a tripped SPD. I have replaced the SPD today in the morning, and now everything is working again. But what does it actually mean if you find a tripped SPD? So we had certainly a kind of over voltage event, and not just a small one, because if the SPD has to pass maximum current through it, there's a varistor inside, then that varistor will at some point not be able to deal with that current, and it will just fail. It will just shorten, and when it shortens, then there is a bridge here, a solder bridge built in here, which will then melt, and it will then pop the mechanism here, which will then show here in the window. But that most certainly means that we also had probably a lightning strike right next. This was on phase 1 here. When I arrived at my Powerwall, I actually found 2 non-working inverters. So one here, phase 3, 1000 watts. That one we know was already broken last year, and I fixed it. The oldest one still alive. Phase 2 is that one, and here the newest inverter, 2000 watt, on phase 1 again. So the same phase as the SPD what we saw before. The 2 main breakers of those phases in the main distribution board has been tripped at that time, and as I said, 2 non-working inverters. So this all suits to some sort of major outside event. If you remember, in one of my last videos I have built in another 3-phase SPD here, surge protection device. That one is okay. It did not show anything in the windows, but that one is also a more potent one which can handle higher currents. So it survived, but it surely did a lot to remove some extra current. Why do I think that it did a good job? We will see this in a moment when we look at the inverters. Let's look at these 2 inverters individually. So this is the 1000 watt inverter. When I have reset the main breaker of this guy, it stayed up. It's also showing by the resistance measurement. The only thing I found is the fuse. The fuse is blown, but if I measure resistance also behind the fuse, there's still 700 or 800 kilo ohms resistance on the AC side, so there should not be a significant damage. What I have to do is replace the fuse, and then let's see if there's something going on. But what could have blown the fuse? So maybe there is again something what happened here on the power supply of the board. So this will be seen then later after I disassemble the board and then do some further measurements. The other one, the Sun 2000 here. So what I found on this one is that if I measure resistance on the AC, I'm getting somewhere around 1200 ohms. That's quite low, but it's not a dead short. But if I plug this now in, there would be a bank somewhere here in this area, and my breaker will then trip. But also here we have the initial fuse, the input fuse, but this one is still intact. So this is telling me that the failure is already somewhere before. But where before can it be? We only have the connector, and then it's already going quite straight to the fuse. There's only one thing here what can be still faulty at the input, and this is here. You can see 2 capacitors and also here probably a varistor. So it is possible, of course, that if there was a surge, that some of these components just blew up. And if I now put the 220 volts on the input, that is of course a higher voltage than what the meter will have when you measure the resistance. Then it will just probably jump over the fault internally of one of these components and cause a dead short. But otherwise I did not find anything burnt or whatever, so I don't think that the transistor side of each of these inverters has a malfunction. It's of course still a hope, but I think that it's only something what happened right at the AC input, and this should be actually quite easily to fix and also not that expensive to fix. And then we are going to do also something more substantial. So as you know, maybe we had the construction here on our street, and this is finished now. Let me show you what we can now do after the work here is done. We now got a new street, we have a walkway, and this is our PV array at the garage. And now I got my space back and I can add another row of solar panels here. So this will be a new array, and that array will also be used for something more than just being a grid-tied system. I wouldn't actually need so much power on one single phase. This is all on one phase, of course. Feeding into the garage, it only would make sense if during the daytime there is an electric vehicle standing here and charging, but otherwise it would kind of overwhelm this phase. So this area will not be just a simple grid-tied system, it will also actually be a new storage system. And not just that, here in my garage there are a few important things connected, and those I actually want to have as a backup in emergency cases. Let me show you quickly what I mean with this. Here on the back of the garage we have our water storage and pump, and at the moment when the grid goes down we will not be able to pump water, so the water is also off. And what I want to achieve with this new array and new system is that it will take over during the time when the grid is down, and also feed the remaining power into the grid. So yeah, this will be a more advanced hybrid system than we have at our off-grid system at the moment. And yeah, I will show you then what kind of inverter will be the best choice for something like this and how this will be built step by step. Yeah, so this is what you will see on my channel in the next few months, and it will be surely interesting, especially when we are building the new hybrid system. I did not decide about what kind of batteries we will use. It will all depend again on what I can get here in Thailand. And as you know, I am not spending too much money on it, so all of this will be DIY and the best bang for the buck. I have to investigate these two inverters a little bit more and see what I have to order, and then I will hopefully show a successful fix of these two inverters. Okay, so thank you for watching this video. Please give me a thumbs up, subscribe to the channel if you haven't yet, and I see you next time.